Series Land Rovers are not noted for the accuracy of their instrumentation. The electrical components were, after all, mostly designed by Lucas. Coupled to another bastion of British reliability, Smith's Instruments, the temperature and fuel gauges are liable to read high, read low, or not at all. The instrumentation circuits are simple. A sender unit offers a variable resistance dependent on the level of fuel in the tank or the temperature of the coolant. This is then measured by the gauge. The needle moves further depending on how much current flows. The gauges are both fed via an interesting little device called a voltage stabiliser. This lives in a small pressed steel box screwed to the back of the speedometer. The voltage stabiliser is a common Smiths part and is found in all manner of British vehicles from the 1950s to the mid-1980s. It provides something approximating to 10 volts from a feed that varies between around 11.5 and 14.2 volts. It works using a bimetallic strip which heats up, bends slightly as a result, and opens a set of contacts, cutting off the current flow. As the strip cools down, it bends back and the contacts close, starting the process again. This continues every half second or so whilst the ignition is turned on. In reality, it does not produce anything close to a constant 10 volts. However, the instruments don't know this, and the damping inherent in their design results in a gauge readout that is more or less steady. However, in a car that is 40 or 50 years old, this switching mechanism might be getting a little tired. Imagine a car that is 50 years old. Assuming a very conservative 5,000 kilometres per year, this equates to 250,000 Ks. Again, assuming a modest 40 kilometres per hour average speed, this suggests around 6,250 hours of engine running time. 6,250 times 60 times 60 times 2 is 45 million operations. No wonder these babies are getting a little temperamental. Help is at hand, though, in the form of a modern voltage stabiliser IC, in this case a Mu A7810 manufactured by Texas Instruments. These are a low-cost, robust device which will provide 10 volts for your gauges, bestowing a new level of reliability on them. 10-volt stabilisers are not all that common and can be a little hard to get hold of. Here in New Zealand I was able to source them from RS Components. Minimum order was 5, so I have a few spares. If anyone local wants one of these, please get in touch. It is possible to modify the Smith stabiliser and mount the IC inside. The case can be opened carefully and the bimetallic nonsense inside discarded, leaving just enough room for the chip. "50 years ago, the guys at Smiths had a machine to fold these edges, and it was good at its job. However, a couple of careful minutes with the chisel, and you should be right." Ah, look at that. Made in England. Once they're cleaned up, the brass strips from the bimetallic arrangement make excellent contacts for the chip installation. And you won't be needing this anymore. The left leg is the input, the right the output, and the tab and the middle leg are earthed. Let's run a quick test before we put the whole thing together. The multimeter is measuring the voltage over the little red lamp, which is there to provide a small current draw, in this case around 80 milliamps, through the regulator. The input voltage can be varied, and once it reaches about 11.5 volts, the output voltage will stabilise at 10 volts. Further input voltage increases do not affect the output, which is what we want. There's nothing particularly fancy about the installation, but it is important to use a heatsink on the legs of the IC when soldering on the leads. If you don't, you'll fry the insides and you'll be going back to your supplier for a new one. The centre leg is just another earth and should be removed. Otherwise it'll just get in your way. A small amount of heat shrink and the electrical installation is almost complete. It's obviously vital to get the polarity right. The input leg is connected to the female spade terminal on the back of the unit, and the output leg is connected to the male spade. Here you can see how the final installation works, with the IC folded back around so that it is hard up against the inside of the housing. After the rivet fest that was Land Rover bodywork repair, I found my stock of smaller rivets was somewhat depleted. Rather than lash out and buy a rivet that actually fitted, it was easy enough to open up the mounting hole in the IC. There. Perfect. A corresponding hole in the housing allows the IC to be fitted neatly with the rivet. The housing then acts as an effective heatsink. With the IC firmly attached and the wiring completed, all that remains to be done is to reassemble the case. It was an absolute nightmare holding it steady in such a way that I was able to fold over the tabs. After taking leave of my senses and starting out on this precision task with a full-size claw hammer, I did eventually see sense and use a slightly more appropriate tool. I tried several different methods, none of which was particularly satisfactory. But by the magic of television, I did eventually complete the job in a few seconds. If you've ever wondered what the little lip on the back of your vise is for, here's one use. After all that precision hammer work, there was just time for a quick test before installing the unit in the vehicle. You can buy these things made up for about $100, but where's the fun in that? Although it's hard to believe, I've found one or two other ways to improve my Series Land Rover. I'll tell you about them next time.